Everyone, so today in this video we'll see a problem on Fourier series. Okay, here it is given if f of x equal to x when 0 is less than x less than pi by 2 and pi minus x when x is greater than pi by 2, expand f of x as a sine series in the interval 0 comma pi. Okay, usually the Fourier series will be of the form 0 to 2 pi. Okay, the period will be 0 to 2 pi, so the period is 2 pi. No, but here instead it is given 0 to pi, so it means it comes under half range. Okay, so if it is given 0 to 2 pi, this is nothing but my Fourier series. Okay, if it is given 0 to pi, then it means it is half range Fourier series. Okay, this is half range Fourier series. So now according to the problem, you can see here it is given sine series. Okay, so you can say that this problem is an half range sine series. Okay, so now I'm going to solve it under the half range sine series. Now we'll start writing the solution of the problem now. So we know that this problem is an half range sine series. Okay, the half range, the formula of half range Fourier sine series is f of x is equal to sigma n equal to 1 to infinity bn sin nx, where bn is nothing but 2 by pi integral 0 to pi f of x sin nx dx. Okay, so now first I'll find the value of bn and then substitute here. Okay, now bn I'm going to find. So bn is equal to, according to the formula, it's 2 by pi integral 0 to pi f of x sin nx into dx. So this is equal to 2 by pi. This is limits. Here according to my given problem, here it is given the limit as 0 to pi by 2 and the other limit is pi by 2 to pi. Here how I am saying it is pi by 2 to pi, here in the given problem it is given 0 to pi, right? So this will be nothing but this will be pi by 2 less than x less than pi. Obviously this will be the limits, right, of this function. So here you can see that here the limits break into two parts. One is 0 to pi by 2 and the other one is pi by 2 to pi. So I'm going to break the limits here. So this is 0 to pi by 2 f of x sin nx into dx plus integral pi by 2 to pi f of x sin nx into dx. Okay, according to my problem, here it is given separately. They have break the limits here, right? 0 to pi by 2, pi by 2 to pi. So for that reason only I am breaking here. Okay, here if it is 0 to pi, then I'll write whatever it is. Okay, since it is given, the two limits are given here, two type of limits are given, so I have separated here according to the given problem now. Okay, so now this is nothing but 2 by pi. So in the interval 0 to pi by 2, so in the interval 0 to pi by 2, f of x is nothing but, you can see here, in the interval 0 to pi by 2, f of x is nothing but x. So I'll write the value in place of f of x, it is x sin nx into dx plus interval pi by 2 to pi. The next limit, interval pi by 2 to pi, you can see f of x is nothing but pi minus x. So this is pi minus x into sin nx into dx. Okay, now I need to find the interval value separately. Okay, so I will write it as equation number 1. Okay, so I'm going to find the interval separately. Okay, so now I'm going to find the first integral, I'll find the value and then I'll find the second interval. Okay, so consider the first integral. Okay, according to my first integral, I can say that this is my u, this is my v, this is my dx. So I'm going to integrate using the Bernoulli's now. So the Bernoulli formula is integral uv dx equal to uv1 minus u dash v2 plus u double dash v3 minus so on. Okay, so this is my Bernoulli's formula, right? Here, according to my formula, u is my x and v is my sin nx. Then u dash is nothing but 1, u double dash is 0. So I have differentiated, I have got the value. Next I'm going to integrate. Okay, if v terms I'm going to integrate. So integration of sine is minus cos nx by n. Then v term I'm going to find. So before integrating, take the constant term outside. The constant term are minus 1 by n. So now integrate. Integration of cos is sine nx by n. So this term can be written as minus sine nx by n square. Okay, so this is my Bernoulli's formula. So now apply it in the Bernoulli's formula. So my given problem is integral 0 to pi by 2 x sine nx into dx. So this is written as according to my Bernoulli formula, integral u v dx. Integral u v dx is equal to u v1. U is nothing but x. So x u v1 is minus cos nx by n. U v1 minus u dash value is 1. V2 is minus sine nx by n square. Then u double dash value is 0. So the next terms are 0. So I'll leave it as it is. And the limits are 0 to pi by 2. Okay, so this is equal to, now multiply the terms here. So this is minus x cos nx by n plus sine nx by n square, and the limits 0 to pi by 2. So now I'm going to write the upper limit and then the lower limit I'm going to substitute. Okay, so now if I substitute the upper limit in place of x, I'll substitute pi by 2. It is minus pi by 2 cos n pi by 2 divided by n plus sine n pi by 2 divided by n square. So this is my upper limit minus the lower limit I will apply. So in place of x I'll put 0. So 0 into cos is 0. So this is the first term will be 0 plus sine 0 by n square equal to minus pi by 2 n cos n pi by 2 plus sine n pi by 2. This is the whole divided by n. This is the whole divided by n square minus 0. Sine 0 is 0. So the next term will become zeros. Okay. So this is the term remaining. Okay. So this is my integral 0 to pi by 2 x sine nx dx value. Okay. Similarly, I'm going to find the second integral. Consider the second integral. My second integral is, according to my problem, this is my second integral. So this is pi by 2 to pi minus x into sine nx dx. So this is my second integral. So I'm going to use the Bernoulli's formula, that is the integral uv dx. So my Bernoulli's formula is in uv1 minus u dash v2 plus u double dash v3 minus so on. Okay, so this is my u, this is my v. So here u equal to pi minus x and v equal to sine nx. U dash is nothing but minus 1, u double dash is 0. Similarly, the value of v1 is equal to integration of cos is minus sine. Sorry, integration of sine is minus cos. So minus cos nx by n. Then find v2. v2 equal to minus 1 by n. Integration of cos is sine. So it is sine nx by n. So then this is equal to minus sine nx by n square. Okay, so now I'm applying the Bernoulli's formula. So integral pi by 2 to pi minus x into sine nx dx is equal to, according to the Bernoulli's formula, it is u v1. U is pi minus xu. V1 is minus cos nx by n. So u v1 minus u dash. U dash value is minus 1. V2. V2 value is minus sine nx by n square. Okay. Then u double dash value is 0. So the remaining terms are 0 and the limits are pi by 2 to pi. Okay. So this is equal to, this is minus pi minus x into cos nx by n. Then here we have 3 minus sign here. So minus into minus plus, plus into minus, minus. So minus sine nx by n square and the limits are pi by 2 to pi. Okay, now I'm going to apply the upper limit and then the lower limit. So upper limit minus lower limit. So this is equal to, so first I'm going to, in place of x, I'll substitute the value of pi. So this is minus of pi minus pi. Pi minus pi is 0. So the whole term will become 0. So this is 0 minus, this is sine n pi by n square. So upper limit I have find now. Okay, I have substituted upper limit. Then the lower limit. For lower limit I'll put minus. Then I'll, in place of x, I'll put x, pi by 2. So it is minus pi by 2 cos n pi by 2 divided by n minus sine n pi by 2 divided by n square. So this is my lower limit value. Okay, so this is equal to, this is sine, this is 0 minus sine n pi. Sine n pi is 0. So 0 divided by n square is 0. Okay, minus, here we have minus pi minus pi by 2 is nothing but pi by 2. So it is pi by 2. What I'm doing here, this minus sign I have written here, and then this minus sign I have written within the bracket. Then pi minus pi by 2 is pi by 2. It is cos n pi by 2 divided by n minus sine n pi by 2 divided by n square. Okay, so if I take this minus inside, this term 0. If I take this minus inside, then this will become plus, this will also become plus. So it is pi by 2 cos n pi by 2 divided by n minus sine n pi by 2 divided by n square. Okay, so this term is nothing but pi by 2 cos n pi by 2 divided by n minus sine n pi by 2 divided by n square. This is my value of the second integral. So I'm going to substitute the first integral value and the value of the second integral in the equation number 1. Okay, so equation number 1 is nothing but bn equal to, therefore bn is equal to 2 by pi integral 0 to pi by 2 x sine nx dx plus integral pi by 2 to pi minus x sine nx into dx. So this is equal to 2 by pi. The value of the first integral is, here it is, the value of the first integral. So I'll write here, this is minus pi by 2 cos n pi by 2 divided by n plus sine n pi by 2 divided by n square. This is my value of the first integral plus the value of the second integral is here. So this is pi by 2 cos n pi by 2 divided by n minus sine n pi by 2 divided by n square. Dear students, that is a correction. Here, since I have multiplied minus inside the bracket, the term will become, it will change sign, right? So this minus will become plus. Similarly, this minus will become plus, okay? So this is plus, okay? And here also it is plus. So if after substituting here, the value here is plus, okay? So as you can see here, minus pi by 2 cos n pi by 2 by n and plus pi by 2 cos n pi by 2 by n, they both are same but different in sign, so they get cancelled. So only these two term remains. So this is nothing but 2 by pi. As you can see here, if you add these two, it is 2 sine n pi by 2 divided by n square. Okay, so this is nothing but 4 by pi n square into sine n pi by 2. Okay, so this is my value. Now if I see the value of sine n pi by 2, sine n pi by 2 is nothing but sine n pi by 2 is nothing but its value is 0 if n is even, and its value is minus 1 the whole power n minus 1 by 2 if n is odd. Okay, so this is the formula of sine n pi. So as I can see here, if I substitute n is equal to 1, this is 4 by pi, I'll take it commonly outside, so it is sine n pi by 2 divided by n square. Okay, now 1 minute, just leave it as it is. Okay, so this is my bn value. Next, the Fourier series of the function is the Fourier series, sorry, the half range Fourier sine series is f of x equal to sigma n equal to 1 to infinity bn sine nx. Okay, so this is equal to sigma n equal to 1 to infinity. The value of bn just now we have found, no, 4 by pi sine n pi by 2 divided by n square. 4 by pi sine n pi divided by 2 divided by n square into sine nx. Okay, so now what I'm going to do is I need to substitute the n value, n equal to 1, 2, like that. Okay, so we need to know that sine n pi by 2, this is nothing but 0 if n is even, and minus 1 the whole power n minus 1 by 2 if n is odd. Okay, this is the condition of sine n pi by 2. So if I substitute this condition, so this will be equal to, so before substituting, take the constant term outside. The constant terms are 4 by pi. So 4 by pi, I'm taking it outside. So the inner value will be sigma n equal to 1 to infinity sine n pi by 2 divided by n square into sine nx. This is my formula. So this is equal to 4 by pi. Now I'm going to substitute. So if I take n equal to 1, and 1 is an odd number, so this will be minus 1 the whole power 1 minus 1. 1 minus 1 is 0. So this is 0 divided by n square sine x. Sorry, n value is 1, no, so 1 square sine x. If I take n equal to 2, n equal to 2 is an even number. So if it's an even number, its value is 0. So the upper value is 0. So 0 into anything is 0. Next, I take n equal to 3. If I take n is equal to 3 here, according to the formula, it is minus 1 the whole power 3 minus 1. 3 minus 1 is 2. 2 divided by 2 is 1. So minus 1 the whole power 1 by 3 square sine 3x. The next term is n equal to 4. N equal to 4. 4 is an even number. So sin n pi value is 0. So the whole term will become 0. The next term n is equal to 5. So if I take n is equal to 5, it is minus 1 the whole power. 5 minus 1. 5 minus 1 is 4. 4 by 2 is 2. Square divided by n value is 5, no, so 5 square into sine 5x, and so on it will go. Okay, so this is nothing but 4 by pi. Minus 1 the whole power 0 is 1. So 1 by 1 square sine x plus this term 0. The next term minus 1 the whole power 1. Minus 1 the whole power 1 is minus 1 by 3 square sine 3x. The next term is 0. Again here next one. This is minus 1 the whole square. Minus 1 the whole square is plus 1. So 1 by 5 square sine 5x. Then the next term will be minus, and so on it will go. Okay. So this is 4 by pi. This is sine x by 1 square minus sine 3x by 3 square plus sine 5x by 5 square. So on it will go. Thus, this is the final answer of the Fourier series. Okay, so therefore the half range Fourier series of the given function is nothing but this value. Okay, so thank you so much for watching. All the very best for your exam. Thank you.